Okay, so the last part of section 2.6 is one more special type of function, and it's called a piecewise function. And really, we've kind of seen this a little bit already, but a piecewise function is basically just a function that has more than one piece. And so it says a piecewise function is defined by two or more rules. To decide the rule you need to use, determine which inequality describes the input value or the domain, and use the corresponding rule. So let's look at what it looks like at first, and before we get to like graphing it, right? So it says evaluate the piecewise function p of x for the different input values. So a piecewise function looks really scary, but it's basically just pieces, right? So there's three pieces here, all for p of x, but notice they each have a rule next to them. So it's 2x if x is less than 0, it's x plus 5 if x is equal to 0, and it's 0.5x minus 1 if x is greater than 0. So those give you the rules. So when it says find p of 10, you don't put 10 in all of these. You only put it in the one that it corresponds to. And 10 is definitely greater than 0. So this means that I would only use this part of the equation. So for p of 10, I would do 0.5, or 1/2, times 10 minus 1. Or half of 10 is 5, and 5 minus 1 is 4. What about negative 10? Which piece would that go in? Well, negative 10 is definitely when x is less than 0. So that means I would only use this. So that would just be 2 times negative 10, or that would be negative 20. What about p of 0? Well, 0 is right here, right? That's only when x plus 5. So 0 plus 5 is 5. What about 2.48? Where would that one fall? Well, 2.48 is bigger than 0, so I would take 0.5 times 2.48 minus 1, and I'd have to get my calculator for that one. 0.5 times 2.48 minus 1 is 0.24. Okay? So don't get scared by all that. It just tells you which piece to use. So it says what input value will give an output of negative 6, or symbolically what would equal negative 6. So can you think of something for that? Like what x value would give me a y value of negative 6? I think it's going to be this one, right? What number could I put in there? 2 times negative 3 is negative 6. Negative 3 is less than 0, so I think p of negative 3 equals negative 6, or when x is negative 3. Okay, so let's look at another one. What if we don't just look at the equation values, but we think about making an xy chart for this? So it says complete the table for the following piecewise function. So this one says f of x equals, and we have two pieces. We have 2x plus 1 when x is less than 2, and we have x squared minus 2 when x is greater than or equal to 2. So again, that tells us what to break up. So think about the 2 is like the dividing line here, right? So I'm going to kind of put a line on my paper here that for everything less than 2, which piece am I going to be using? Well, I'm going to be using the 2x plus 1. And for everything 2 or greater, those are all greater than 2, I'm going to be using x squared minus 2. And then f of x, those are just my y values. So if I plug negative 3, I'm not going to show my work for all of these, but 2 times negative 3 plus 1, negative 6 plus 1 is negative 5. If I plug negative 2 in there, 2 times negative 2 plus 1 would be negative 4 plus 1 is negative 3. 2 times negative 1 is negative 2 plus 1 is negative 1. If I plug 0 in there, that's going to be 1. Maybe you see the pattern here. If I plug 1 in there, 2 plus 1 is 3. If I plug 1.5 in there, 2 times 1.5 is 3, right? Plus 1 is 4. But what about on this side? When it's greater than or equal to 2, I have to use this piece. So that would be 2 squared minus 2, or 4 minus 2 is 2. If I plug the square root of 5 in there, you can do that on your calculator, but what happens when you square a square root? It just cancels out, and 5 minus 2 is 3. If I put 3 in there, 3 squared is 9, and 9 minus 2 is 7. All right, so that would be filling the chart in. And this one says, which piece of f of x is not linear? Well, we've talked about linear and not linear. If x is squared, it's not linear, right? So x squared minus 2 is not linear. 2x plus 1 is linear. Okay? So let's look at it another way. You might think this is a silly idea, but piecewise functions actually show up a lot. It says, consider the following scenario. Braylon wants to join a gym. If he joins for 7 months or less, it will cost him an initiation fee of $40 plus $12 per month, including the first month. If he joins for more than 7 months, it will cost him $130 for the whole year. If x equals months, complete the table to show how much Braylon can expect to pay depending on the number of months. So think about this. If he only joins for 1 month, right? 1 month, it's $40 plus $12 per month, right? So for 1 month, that would be 40 plus 12. So that would be $52. And if he joins for 2 months, what would that be? Well, I'd have to pay plus 12 again, right? Or I could think 40 plus 12 times 2, right? Or 40 plus 24 is 64. And I'm just going to keep increasing by 12 until when? If he joins for 7 months or less. So 7 months or less. So up to 7 months, I'm just going to keep adding 12 to this. Are you okay with that? So that would be 76. And then plus 12 for the next month would be 88. And then plus 12 for the next month would be 100. And then plus 12 for the next month would be 112. And then 124. Or if he joins for more than 7 months, so 8, 9, 10, 11, 12, it'll cost him $130 for the whole year. So how are we going to write that? That at 8 months, it's $130. If he joins 9 months, it's still just $130. For 10 months, it's $130, right? Like, that just stays the same. For 8, 9, 10, 11, or 12 months, it's $130. So think about what that equation would look like. I definitely agree that we have 2 pieces. What would the first piece be for this equation? If x is the number of months, I kind of got it here for you already, right? If x is the number of months, it would be $40 plus $12 per month. And then we want to say, what's that true for? So that's a comma. That's true for 7 or less months. So that's when x is less than or equal to 7. But what happens when x is greater than 7 months? How much does he pay? Does it matter how many months he has? No. For the whole year, we could just say that's 130. That's just a straight line on there. All right? And so then we can write our own equation. Okay, I think I got a couple more here. So now we want to look at graphing it. So we'll save that one for class. So number 4 says graph the piecewise function negative x when x is less than or equal to 0 and x when x is greater than 0. It says first make a table of values. Include at least one fraction and make one decimal input. And so we definitely want to think about dividing this. I'm going to divide it in half, okay? So we're going to make this our dividing line, which is 0. Which side is 0 going to be on? Which side is it included? It's included over here, right? So let's pick numbers less than 0. So let's pick like negative 2. Let's pick negative 1.5. That should have been the other way around. Let's pick negative 7. And when x is less than or equal to 0, we're going to use this equation. So that just means I'm going to change the sign of everything, right? Oh, I don't want to pick negative 7. It doesn't go on my graph. I want to pick negative 4. And if I do negative of negative 4, it's positive 4. And this one's just going to become positive 1.5, positive 2, and 0, because it just changes the sign. And over here, let's pick numbers bigger than 0, like 1, and let's pick 3 over 2, which is 1.5. Let's pick 2, and let's pick 4. And on this one, it's just x. So whatever I plug in, I get the same thing back, right? So this would be 1, 3 halves, or 1.5, 2, and 4. So now plot the points to make the graph. Hint, draw your axis based on your point. So notice all of our y values are positive, so I'm not going to really make a lot of y values negative. So I'm going to make this my x-axis, and I'm going to make this my y-axis. And I'm going to change colors here for you. And I'm just going to plot the points. At -4 on the x, I got 4. At -1.5, I got 1.5. At -2, I got 2. And at 0, I got 0. At 1, I got 1. At 1.5, I got 1.5. At 2, I got 2. And at 4, I got 4. Is that right? So if I draw that graph, it kind of looks like this, right? I don't know why that seems off so much. That's a V-shaped graph. This is the left side, this is the left piece, this is the right piece. Notice it says this has a graph, a name is called the absolute value function, because you don't need to break it up in two different ones, that this is the same as saying absolute value of x, okay? It's an even function if you want to say that as well, but that is a piecewise function. Where's my time? 11 minutes. Okay, so this is the last one. I want you to read through this, look at it, and see if you can come up with the answers, and then we'll talk about this in class tomorrow and practice some.